Alright, and Assalamualaikum. In this video, I'm going to teach for the integration using the substitution technique. So mainly we call this as U substitution. But before we could do the U substitution, let's just look at this example. So what if we have to integrate this? Alright, this is very easy because if we have to the power of 2 here, all right, x plus 3 to the power of 2, we can expand it. So we can actually simplify this by having, like, for example, x minus 2. You expand that x plus 3 to the power of 2, we'll get x squared plus the 6x plus 9 dx. Don't forget that dx, most of the students leave this dx, all right? So we can still expand this x with x squared, x with 6x, and also x with 9x. So we'll have something like, this is integration, all right? We have not integrated it, all right? We are going to simplify this first, x to the power of 3 plus 6x to the power of 2 plus 9x, all right? And then we have to expand that negative 2x squared minus, all right? And then minus this, also have something like minus 2x squared minus 12x minus 18, and then we have the dx. So we try to simplify this first before we can integrate it, all right? X to the power of 3 plus, all right, 6 and minus 2 will get 4x squared, and we have 9 minus 12 we get negative 3x, and then we have minus 18 dx. All right, so now we want to integrate this. All right, now it can be integrated. So this is very easy because we can integrate x to the power of 2 will become x to the power of 4 over 4, and then integrate 4x to the power of 2, we'll get 4x to the power of 3 over 3, and then we have this negative 3x, we'll get negative 3x squared over 2. All right, that one is square over 2. Be careful when writing your numbers. All right, and then finally we'll get constant, we'll get negative 18x, but don't forget that plus c because this is the indefinite integral. But what if you have something like this? You have x minus 3 to the power of 4. All right, so the power is very big now. So you try to expand, but you still can do this, but it's long. So what you can do is actually using the, what we call it as the substitution method. So usually we call this as U substitution, meaning to say that in this case, all right, so you have to take this as U, all right? So you take U equal to x minus 3. So you differentiate this U, will get du over dx is actually 1. So you want to make dx as the subject. So du is equal to dx, all right? So dx is equal to du. All right, so dx is equal to du in this case. All right, so now we have this as the, all right, so this x minus 3 has become u at u to the power of 4. That dx must change to du. You don't write dx. Why? Because this is actually u, but this is x, so it is not matching here. So you have to, that's why you have to find this, right? You have to find this first before you could integrate it. So this dx will become du. Why? Because we have this equation, right? So now we are going to integrate in terms of u. So actually in this case you will get, all right, using the power technique, variable technique, u to the power of 4 plus 1, u to the power of 5 over 5, which is the new power, plus c. So this is our final answer. But how to do this when we have the definite integral? It's almost similar. It's just that, all right, so firstly we'll have to choose this as u. So u is equal to x minus 3. So we have the du over dx is equal to 1. So dx is of course equal to du. But now, because it is definite integral, so this is the value of x because it is in terms of x now. So we have to write this when x is equal to 3. So you will have u is equal to, all right, you substitute 3 inside this function. We'll get 3 minus 3 will get 0. And then again, we have to find the value of u when x is equal to, 4. So we'll have to find the u, which is given by, all right, u is given by the function, sorry, u is given by, all right, x minus 3. We substitute 4 inside this function, so 4 minus 3 will get 1. So meaning to say that at the place 3 will become 0. At the place x equal to 4 will become 1. Alright, so we transform this to be, right, at 3 will become 0 and at 4 will become 1. X minus 3 has already been u, so u, and dx must be du. So everything is in u. So we know that this is the value in term of u, right? So integrating u du, so of course u to the power of 1, so this is using variable technique. We'll have u to the power of 2 over 2, right? U to the power of 2 over 2. I'm sorry, be careful, right? Because this is not actually u, because this is actually u to the power of 4. Because we just substitute this with u, so that 4 must be written as the power. So integrating this, we'll get u to the power of 5 over 5, but we have to find this for the value of 0 to 1. Alright, so to do this, so we can actually take 1 to the power of 5 over 5 minus 0 to the power of 5 over 5. So this is actually given by 1 over 5 is the final answer. So it is different from this. This one have plus c because it is definite integral, but this one must get a value, a fixed value for the definite integral. Alright, so let's look at number 2 now. Alright, so what if we have this type of function? So it is very difficult for us to expand x that to the power of 3. So what we could do is actually using this u substitution. So we'll just substitute u is equal to 10 minus 2x. Alright, so we differentiate this first. We'll get du over dx is actually negative 2. Right, so du is actually given by negative 2 dx. So negative 2 dx is actually du. So I want to make dx as the subjects. Of course, I'll have du over negative 2. Okay, so we try to substitute into this integral. All right, so we'll have something like, all right, this part will become, right, this has already been u given by this. All right, so u to the power of 3. That dx, right, you don't write dx here. All right, you don't write dx, but dx must be written as du over negative 2. So we'll have du over negative 2. Because this negative 2 is a constant which is not involved in with the integration, we can take out that negative 2. So that will become negative 1 over 2. So now we just want to integrate u to the power of 3 du. Alright, so differentiating u to the power of 3 will get us, alright, so that negative 1 over 2, you just write it. U to the power of 3 will become u to the power of new power, which is 3 plus 1, which is 4, divided by the new power, which is 4, but in this case, we'll have to plus c. So our final answer can be simplified as 1 over 8 u to the power of 4 plus c for this type of question. Alright, so what if we have the definite integral for this? Alright, so again, we are just repeating the same thing. So the procedure is to make this as u. So u substitute this with 10 minus 2x. So du over dx is actually negative 2. So I'll just write dx is equal to negative 1 over 2 du. Alright. So because now this is the value of x, so and this is the value of x, so we have to find the value of u when that value of x is equal to 4 and 5. So when x is equal to 4, so we have to find u. So u is equal to, you substitute 4 inside this function. So 2 minus 10 minus 2 multiplied by 4, this is given by 10 minus 8. So 10 minus 8 is actually 2. Right, and then we have to find when x is equal to 5, right? So we can find the value of u. We can substitute again in this function. So 10 minus 2 multiplied by 5. So 10 minus 5 is actually 0. So we try to change everything in terms of u now. All right, so we will have something like, all right, 4, all right, at the place 4 will become 2. And then we want to make 5. At the place 5 will become 0, from 2 to 0. And then this part will become u, but u to the power of 3. And dx will become this negative 1 over 2 multiplied by negative 1 over 2 du. Alright, so we note that we have u du, something like this. Alright, if you still have this dx, but this is u, you have to make some corrections. Alright, so there must be something wrong. My strategy is to bring this negative 1 over 2 outside because it is a constant which is not involved with the integration. So I'll have negative 1 over 2. You better write it carefully. Alright, so we'll have negative 1 over 2. And then we'll have that integration of from 2 to 0 u to the power of 3 du. Alright, so now we will have this. Alright, so we try to integrate that u to the power of 3. We'll get u to the power of 4 over 4. Alright, so from 2 to 0. So we try to substitute the value of u with, we have to always substitute with the value at the upper parts first, which is 0. So in this case, we'll have negative 1 over 2, 0 to the power of 4 over 4. We have to minus. Next, we have to substitute the value of u with 2. So we'll have 2 to the power of 4 over 4. Alright, so we'll have something like this. So simplifying this, we'll get negative 1 over 2. This part will become 0. Minus 2 to the power of 4 is actually 16 over 4. So 16 over 4 is actually 4. So we'll have negative 1 over 2, negative 4 inside the bracket. So negative multiplied with negative, we'll get positive. 1 over 2 multiplied by 4, we'll get 2. So 2 as the final answer, which is a fixed number here because it is a definite integral. Alright. So now, let's see question number 3 here. What if we have something like this? Alright, so we cannot use u over v because we don't have the u over v technique for the integration. Alright, so that one is only for differentiation. So what you could do is actually you have to use the u substitution. In this case, which function should be substituted? All right, is it x? All right, let's say you choose x. So ux equal to du over dx. Is there any function that can be cancelled here? Because you still have x squared to be cancelled here, right? So that means your choice of u is actually wrong. So what you could do is actually you try and error for this type of question. But in this case, it is clearly that 1 plus 2x squared must be substituted with u because so we'll have 1 plus 2x squared. So differentiating this, du over dx will give us 4x. All right, we know that this x with x we want to cancel later. All right, so now you must write this dx as the subject. So du equal to 4x dx. I'll just write 4x dx is equal to du. So I want to make dx as the subject, so I'll have dx is equal to 1 over 4x du. All right, so now I'm going to substitute into this. All right, so we will have this as integration of this part we have not substituted with anything, but this is 1 plus 2x squared will become u, and then this dx must be used this function. All right, so we'll have 1 over 4x, we have du. And we note that we have u, and x. This is the problem, but we can cancel the x with x here and here. So we have no more x. So now the function is all in terms of u. So we try to simplify this. All right, I'm going to bring this 1 over 4 outside the integration because it is not involved with the integration. So I'll have 1 over 4 integrate of 1 over u du. All right, before this, we know from the technique of integration, 1 over u will become ln u. So we will have 1 over 4 ln u plus c. You want to have modulus or you don't want to have modulus, it's okay. So we note that we finally have to write the function in terms of x. All right, so in terms of, I forgot to rewrite this in terms of x because when you have this, for the question number 2 just now, when you have the same goes to number 1. All right, you already got the u as the final answer. Of course, you have to write it back as x minus 3 to the power of, now it is 5 over 5 plus c. All right, you have to rewrite it as in terms of x. So this one also goes to there, right? So because you already substitute u with 10 minus 2x, so you go back and you have to substitute with 10 minus 2x to the power of 4 plus c. So again, for this type of question, so ln of u is given by this 1 plus 2x squared. So you have to put that 1 plus 2x squared in the modulus, 1 plus 2x squared plus c. All right, so our final answer must be in terms of x because the question given is in terms of x. All right, so now we have question number 4 here. All right, so can you guess which function to which term should be substituted with u? All right, if you substitute this with u, and then when you differentiate that, we will get 4x. But now we want to cancel this x cubed. All right, so actually the function that need to be substituted is actually 2 plus x squared. So we'll have u is equal to 2 plus x cubed. All right, so differentiating this will give us, all right, 3x squared. Right, so we want to make dx as the subject, so du is equal to 3x squared dx. So we'll have 3x squared dx is equal to du, and final answer will be dx equal to du over 3x squared. All right, so now we go back to the initial function. All right, we'll have something like integration. This part we have not substituted with anything, you just write it down. Right, that part will become square root of 2 plus x squared has become u. So I'll just write u. Dx will become this function. So du over 3x squared. Right, so now we note that this x squared with x squared is cancelled now. And I want to bring 2 and 3 outside the integrand. So we'll have something like 2 over 3 integration of 1 over that square root of u can be written as u to the power of 1 over 2 du. All right, so before we could integrate this, I'll just rewrite this as 2 over 3 integrate of u to the power of 1 over 2. I bring it up, so it will become u to the power of negative 1 over 2 du. So we can use the variable technique. In this case, we'll have, all right, so we'll have to plus 1, 2 over 3. So we'll have u to the power of negative 1 over 2 plus 1, we'll have 1 over 2. We have to divide with the new power, which is 1 over 2, plus c. So we can simplify this, right? So we'll get that 1 over 2, all right? So we'll have 2 over 3. This one will actually give us 2 square root u, all right? So this can be simplified as 2 square root u, all right? So plus c, but we don't want, okay, we can multiply this 2 with 2, it will become 4. So we'll have 4 over 3 square root u, but square root u, what is u? U is actually given by 2 plus x cubed. So we'll just rewrite it as square root of 2 plus x cubed in the square root, all right? So we have that plus c at the back there because it is the indefinite integral. So we are done with this one, okay? So maybe the last one, we can see that function here, right? So it is obvious that we have to substitute this with u. So that will have something like u is equal to 1 over 2x squared minus x. So differentiating this will give us du over dx will give us x. Yes, just x minus 1. All right, so we want to make du over x minus 1 is actually dx. So dx is the subject. All right, so now we will have this as, all right, I'll just rewrite this x minus 1, we don't change anything, so it will become x minus 1. That will become square root of u. Dx will become, all right, so dx will give us this du over x minus 1. And we know that we can cancel this x minus 1 with x minus 1. So we only have this square root of 1 over square root of u du. So we can change the form to be something like u to the power of negative 1 over 2 du. So we can use the variable technique. So that power will become negative 1 over 2 plus 1 will become 1 over 2. So we'll have 1 u to the power of 1 over 2 plus c. And we note that This can be simplified as 2 square root of u plus c. And finally, substitute the value of u with this half x squared minus x. So we'll get 2 square root of half x squared minus x plus c. Thank you.